Hello everyone, welcome to my channel. In this video I have two integrals to work on. The first one is this one here, which is the integral from 1 up to 2 of the determinant of this 2 by 2 matrix, 2 rows and 2 columns, 2 by 2 matrix dx. So we have to work out the determinant and then integrate as follows. So this is the first question. I just want to remind you of the definition of the determinant. Suppose we have a 2 by 2 matrix of the form, so this is our solution or answer. Suppose we have a 2 by 2 matrix. Let's say A is equal to a matrix of the form A, B, C, D. That's a 2 by 2 matrix. The determinant of A, also written as det of A, we can also write it as A with two lines like this. When A is a matrix, these two vertical lines represent the determinant, and by definition it's going to be the product of elements on the right diagonal. This is called the right diagonal and that's called the left diagonal. The product of elements on the right diagonal minus the product of elements on the left diagonal. That's the determinant. That's what it means in linear algebra. And therefore, when we look at our integral, so this is our number one, answer number one. When we look at the integral from 1 up to 2 of the determinant of x minus 2, x squared, and then we have minus 5, and then we have x dx. This is the same as the integral from 1 up to 2 of, watch this, the product of those two elements, x times x minus 2 minus the product of these two elements, which is x squared times minus 5, and then dx. Look at how it simplifies. Now we carry on as follows. In our next step, this is the same as the integral from 1 up to 2 of, this will be x squared minus 2x, removing those brackets, distributing this x here, and then simplifying there, you know, we have a minus and a minus there. It must give us 5x squared dx. Right, taking it to the next page, just to finish this off, very simple. The next page, what do we have? We have the following. So what we have now is, remember these are like terms, this one and that one are like terms, we have to add them. And so what we have now is, this is the same as the integral from 1 up to 2 of 6x squared minus 2x. And then we have dx. You can see that that's 5x squared plus x squared is 6x squared minus 2x dx. Let's evaluate the two integrals. Of course, treating 6 and minus 2 as constants. This is the same as 6 times x cubed. Remember, we add 1 and then divide. Minus 2. Remember, there's the power of 1 here. We add 1 and then divide. The limits of integration are 1 to 2. Now let's simplify this. So this is the same as this into there is 2 and this cancel. So we have 2x cubed minus x squared, limits of integration 1 up to 2. Carrying on, we have 2 open brackets, 2 cubed minus 2 squared, then minus open brackets. We now put 1 there and there. 2 times 1 cubed minus 1 squared. And what do we have? This is 2 cubed is 8 times 2 is 16 minus 4 minus in brackets. We have 2 minus 1 as you can see. So what do we have? We have 16 minus 4 minus 1. And this is 12 minus 1. Our answer is 11. So this is the final solution to this integral here that we have been looking at, which is this integral as you can see. So it ends up with 11 as our final solution. Moving on to the next one, still on the same concept. I just want to show you two different forms in which these questions come. Here is question number 2. As you can see, we're still dealing with the determinant. Here we have a vertical lines form, and here it's written det. And if you remember here, I told you that det means determinant. Det A is the same as that which is by definition product of elements on the right diagonal minus product of elements on the left diagonal. So we're going to use the same understanding on this one as follows. So let's capture the question. We have the integral of det in a short form for determinant of 2 3x squared minus 2x plus 1 dx. So how does this work? Where this is the same as the integral. Remember, product of elements on the right diagonal, 2 times x plus 1 minus 3x squared times minus 2 dx. Now, simplifying this, what do we have? The integral of 2x plus 2, and then obviously you can see there we have positive 6x squared dx. Let me just write this in descending powers of x. We have the integral of 6x squared plus 2x plus 2, and then we have dx. Using power rule, this is the same as 6x power 3 over 3 plus 2x power x power 2 over 2 plus 2x, and then plus our constant of integration. Simplifying this, we have our final solution, which is 2x cubed, because you can see there's a 2 there, and then plus x squared plus 2x, and then plus c. That's our final solution to which integral? To this integral here, and indeed our final solution and final question in this short video. Tell me what you think about this. I hope you found that interesting. Integration is very vast. There's no way we can exhaust it, and I thought I should bring in another dimension to this broad spectrum of maths called integration. All right, I'll see you in the next one. In the next one, I'm gonna be looking at some simple, starting with simple algebra questions. Maybe this one here. This is what I want to tackle it in the next video. I want you to attempt it, and let's see what you think would be the solution. The square root of x to the power square root of x, the power square root of x, power square root of x, continuing without stopping, is equal to 2. We're supposed to solve for x. All right, I'll see you in the next one.